So let's talk about how we can name acids. So there are two main kinds of acids, the binary acids and the oxyacids. So the binary acids are composed of two elements. One of them is going to be hydrogen, since it's an acid, and a nonmetal, giving a general formula HX. And they're aqueous because they're acids. They become acids once they've dissolved in water. So some examples, HCl and HF are binary acids. The oxyacids also have hydrogen, and then their anion is an oxyanion. So those are, if you remember back from earlier studies, the polyatomic ions containing oxygen and another element. So nitrate, sulfate, phosphate, those guys. So some examples are HNO3, H2SO4. So how do we name these? So let's look at binary acids first. So here's HCl. So previously we have just named that hydrogen chloride, which when it's a gas, that's what it is. But once it becomes dissolved in water, it's now an acid and needs to be named differently. So how do we do that? So we start with the prefix hydro. Then we're going to add a root that's formed from the name of the nonmetal. So for HCl, it's chlorine, so we're going to have chlor. If it was bromine, we would have brom. If it was nitrogen, we'd have nitra. So a root from the name of the nonmetal. Then you're going to add the suffix ic and the word acid. So hydrogen chloride becomes hydrochloric acid. Now how about those oxyacids? So when you have an oxyacid, it does not start with hydro. So there's no hydro. That's how you can tell the two apart when you're going in the other direction, right? If it starts with hydro, that means it's a binary acid. The oxyacids don't start with hydro. And the names of the acids are similar to the names of the polyatomic oxyanions, only we're going to change the suffix. So if the anion ends in ate, phosphate, sulfate, nitrate, then when you change it to the name of an acid, you're going to change the ate to ic. If the anion ends in ite, so if you remember, we had that series of 4 oxyanions, right? So we went from the ate version to the ite version when we lost an oxygen atom. So if the anion ends in ite, the suffix of the acid is us, O-U-S. Also, if there's a hypo, so remember it's hypoite when we lost another oxygen, or per with the ate when we gained an oxygen, they remain as part of the acid name. And then we add the word acid. So you can remember that potentially using this little adic-itis. So it seems like some sort of illness, or maybe you're getting tired of chemistry and so you have adic-itis. But that's a way to remember which ones go with which. So let's look at some examples. HClO3. So the first thing you're going to do is identify what the oxyanion is, the polyatomic ion. So in this case, it's ClO3, which is chlorate. So we're going to change the ate to ic, and we're going to call this chloric acid. Next example, identify the polyatomic ion. So this is SO3, which is sulfite. And so we're going to call this sulfurous acid. So there's a little bit of a change there because we add back in that sound. It's not sulfus acid, but sulfurous acid. It just sounds a little better. And then the next one, so the polyatomic in this case is NO4. So you would figure out that that is pernitrate. So we would call this acid pernitric acid. Change the ate to ic. So how do we go in the other direction? If we're given the name, how do we figure out the formula? And we do this exactly the same as for ionic compounds. We're going to use the crossover rule. So you write the formula of the hydrogen cation, and then the anion, either the nonmetal or the polyatomic. When the acid name starts with hydro, that tells you that the anion you're going to use is a single nonmetal. If it doesn't start with hydro, then you need to use a polyatomic ion. Determine the subscripts by crossing over the magnitude of the charges, right, ignoring the signs. Reduce the subscripts to the simplest ratio, and then you'd have the formula of the acid. So let's look at some examples. Hydrosulfuric acid. So the hydro says this is a binary acid, so we have hydrogen and we have sulfur. Right, so we have the hydrogen cation, the sulfide anion. So we're going to cross those over to give us H2S. Now here's sulfuric acid. So the fact that the hydro is missing tells us we're not dealing with sulfur here, but rather we're dealing with the sulfate anion. So we've got a hydrogen cation and the sulfate anion, which is SO4 2-. Cross them over, H2SO4. Okay, so it's a small change from hydrosulfuric acid to sulfuric acid. They're very different things. And one more example, hypophosphorous acid. So it doesn't start with hydro, so we're dealing with a oxyanion. So again, we have that hydrogen cation, and so we want the hypophosphite ion, which is PO2 3-. And then we're going to cross them over to give us H3PO2. So that's how you can properly name an acid or determine the formula of an acid.